Ever struggled to debug FastMCP tools because you can't see what's happening inside them? We'll implement real-time logging at different severity levels, debug, info, warning, and error, so you can track exactly what your tools are doing as they execute. The pattern uses FastMCP's context object to send structured logs back to the client, giving you full visibility into tool behavior without modifying your core logic.
Await CTX, debug, starting analysis. Await CTX, info, F processing, len data, items. Await CTX, warning, deprecated parameter used. Await CTX error, processing failed.
This demonstrates the context object pattern for cross-cutting concerns in RPC frameworks. The context object provides a standardized interface to access request-scoped capabilities like logging, progress reporting, and state management, without polluting your function signatures with framework dependencies. What makes this distinctive is its dual role as both a dependency injection target and a runtime service locator, giving you flexibility in how you access it. The pattern works by encapsulating all request-specific operations behind a single, type-hinted interface. Your business logic remains clean and framework-agnostic, while the context object handles communication with the RPC layer, client updates, and request metadata. This separation of concerns lets you write pure functions that become RPC-capable simply by accepting the context parameter, without any framework-specific imports or inheritance. This approach solves the common problem of framework leakage into business logic. Instead of scattering logging calls, progress updates, and metadata access throughout your codebase, you centralize them through a single, well-defined interface. It's particularly valuable for long-running operations where client feedback is critical, or in multi-tenant systems where request context determines behavior. The trade-off is a slight dependency on the context interface, but the benefit is code that's both RPC-ready and testable in isolation. Let's break it down line by line.
Await CTX, debug, starting analysis.
This logs a debug message through the context object, signaling the start of an analysis phase. All FastMCP tools should use this CTX parameter for consistent logging and progress reporting. Debug-level messages help trace execution flow during development without cluttering production logs.
Await CTX, info, F processing, len data, items.
This logs progress information through FastMCP's context interface. The F string dynamically includes the item count, providing real-time feedback during batch processing. All FastMCP tools should use this context parameter for consistent logging and progress reporting.
Await CTX, warning, deprecated parameter used.
This emits a warning-level log through the FastMCP context interface, flagging deprecated parameter usage. Context's logging methods standardize progress reporting across tools, with warnings specifically for non-critical issues that need attention. The await ensures a sync-compatible logging in the event loop.
Await CTX error, processing failed.
This logs a critical error through FastMCP's context interface, ensuring the failure is properly surfaced to both the execution logs and any monitoring systems. The CTX parameter follows FastMCP's standard pattern for unified logging and progress reporting across all tools. Unlike CTX, debug, or CTX info, this level indicates a blocking failure that requires attention. FastMCP context logging. The context object's logging methods provide structured, level-specific communication channels between tools and clients, with debug, info, warning, and error each serving distinct operational roles. Progress reporting requires integer values for both progress and total parameters, never percentages or floats. This pattern transforms raw execution details into actionable client-side intelligence, without altering core logic.
The log message that speaks to no one becomes the conversation that guides everyone.